Hello, everyone. A very good afternoon to one and all present here. Hope you all are doing well. We welcome you all to the 7th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2022. This series will target state-of-the-art as well as emerging topics pertaining to ICT and effective strategies for its implementation for engineering and managerial applications. The objective of this international conference is to provide an opportunity for the researchers, academicians, industry persons, and students to interact and exchange ideas, experience, and expertise in the current trend and strategies for information and communication technology. The main aim of the conference is to provide an opportunity for professionals and researchers to present research findings, to gain experience in the field, receive valuable input from experts about how to strengthen their work, and disseminate exciting and cutting-edge findings from their field of study. I kindly request you all to please keep your mic on mute mode so that it will be easy for everyone to listen to the speakers. Now, to start with the formal session, I would like to invite Dr. Amit Joshi to address the inaugural session. He is the organizing secretary of ICTCS 2022 and currently the director of Global Knowledge Research Foundation. Dr. Joshi has an experience of around 10 years in academic and industry in prestigious organizations. Currently, Dr. Joshi is the international chair of InterVIIT at International Federation of Information Processing, IFIP, Austria. He has presented and published more than 50 papers in national and international journals, conferences of IEEE and ACM. Dr. Joshi has also organized more than 50 national and international conferences and programs in association with ACM, Springer, and IEEE, to name a few, across different countries, including India, UK, Europe, USA, Canada, Thailand, and many more. Dr. Amit Joshi, over to you, sir, for your further answers. I think Dr. Joshi is not here. Maybe he's facing some technical issues. So we will move further to our next speaker. And I would like to invite our first speaker, Dr. Nilanjan Dey. Dr. Nilanjan Dey is an associate professor in the Department of Computer Science and Engineering, Techno International, New Town, Kolkata, India. He is a visiting fellow of the University of Reading, UK. He also holds a position of adjunct professor at Ton Duc Thanh University, Ho Chi Minh City, Vietnam. He is the editor-in-chief of the International Journal of Ambient Computing and Intelligence, IGI Global. He is the series co-editor of Springer Tracks in Nature-Inspired Computing, data-intensive research series, co-editor of Advances in Ubiquitous Sensing Applications for Healthcare, Elsevier. He is an associate editor of IET, Image Processing, and editorial board member of Complex and Intelligent Systems, Springer. Dr. Nilanjan Dey, welcome to the session, sir, and over to you for your further address.
Yes, Anisha, Dr. Dey is on the queue. Just accept the invitation, so he will be there.
Okay, sir.
Am I audible now?
Yes. Now you're.
Am I audible now? A very good morning, good afternoon to all of you. So I'm trying to give a small theme address of this conference. It's not a technical talk. So if you look into this image, you will see, actually we started from society 0.0, that was a hunting society. Then we gradually moved to industry society, that is society 3.0. And then after that, 4.0, that is the information society. And then finally, 5.0, that is super smart, the society. And in the parallel, from society 3.0, there was light industry, the heavy industry also, like starting from the textile to the electricity, the petroleum, etc. And then in society 4.0, we moved to automation, where the computer and the internet introduced. And then 5.0, there is a digital transformation. We move into IoT, then AI and blockchains and everything. Now, if you look into society 5.0, our major focus was something to the problem solving and the value creation to make the things diversified more. And ultimately, they should be sustainable and environmental, the harmony should be there. So in cases of, once we talk about this sustainability, there are 17 different goals of sustainable computing, sustainable development, SDG, those goals. And these all society 5.0, they are somehow linked with all those sustainable development goals through some different technologies, IT-enabled technologies, IT technologies. So information technologies and communication, takes a leading role just to interface between the society 5.0 and the sustainable different goals to achieve that. So it may be AV, it may be AR, VR, maybe starting from the cloud, fog, edge computing, etc. Up to this drone sensors and all these things. Somehow they are differently linked with all different goals. So as we all know, this ICT, actually information technology and communication technology. And if you look into the research, you will published in recent maybe one day. Initially in 1996, actually it started ICT in 19 parts of, so it's a different countries are all contribution from state, UK. Am I audible now?
Yes.
Okay. So from documents countries, if you find, you will see initially major contributions from states, UK, European countries like Spain, India, and China. Now, ICT research, lots of work, almost 50% major work published in articles. Half of this 29-30% in conference, and rest are in different other avenue. And in subject area, if you consider, you will see majority of the work are carried out in computer science, social science, and engineering. That is almost 60% near about, and remaining are from other areas like medical science or mathematics and environmental studies, etc. And regarding the sponsored, mostly European Commission, they used to fund for these projects, these ICT-based projects, even Horizon 2020 also. So these are few of the funders who are actually funding for ICT research. Now, talking about ICT in very recent time, last 2-3 years, there is a dramatic change, you can say, paradigm shift in two different areas. One is in the healthcare sector, and another is the education sector. So in healthcare sector, starting from how you are acquiring the data, how you are processing, how you are communicating, the sensing part, everywhere there is a lots of ICT applications, ICT enabled works has been carried out. And if you look into different layer of ICT, you will see the pillars like wearable devices, the social media, 3D printing. There is a paradigms like fog computing, cloud computing, edge computing. These are all there. And there are new terminologies also come from starting from 2011, that is IoMT, WIoT, or say Internet of Nano Things, Health Things, etc., etc. And all are actually somehow related with this ICT paradigm shifting. I mean, contributing in this paradigm shifting. And the last one is the last top tier one, that is the ICT based healthcare paradigms, where the ubiquitous sensing or the pervasive computing takes a leading role. But in during this pandemic period in last 2-3 years, there is a, I mean, growth of telemonitoring and telemedicine. So lots of ICTs we have observed in this particular area. And besides this, in education sector also, I mean, it's collaborative learning, distance education, learn from anywhere. All these areas, ICT plays a significant role. So I'm just trying to highlight these two particular areas apart from all others area, because these are the two areas where mostly, I mean, we have gone through lots of paradigm shifting. So that is why I'm trying to highlight these two areas. So what next? The next, actually, we started from, I mean, this electrification, automation, and we are now moving to personalization. So it was, once we are in the 4.0, basically we have talked about the robotics, but in 5.0, our target is to deal with the cobots. So it should be collaborative robots. So more personalization, maybe we are moving towards the metaverse, but different challenges are there. Lots of issues are there. Like say, for example, one particular area I can tell in ICT healthcare, once you are trying to deal with the different sensors, the portability of the sensors, the cost of the sensors, that is an important factors. Like once we are dealing with the images, the acquisition procedure, you are dealing with the diacom data or say QTV data, that is also plays a significant role. The data is, I mean, perturbated data or the noisy data, how good the data is. So this is very important thing. And talking about the processing part, different classifiers and machine learning algorithms and all these clustering algorithms, then gives us, I mean, very nice results and lucrative results. But in reality, it's always needs some validation. So trust model needs to be built up, where the transferability and as well as the explainability of the model needs to be explored more. And more, I mean, ultimately, what actually the major challenge of this entire healthcare, that is the data privacy and security policies for different countries. They have different rules and different policies. So we need to go through all these things. So I'm trying to focus on very few of the challenges, but there are lots of other challenges also associated with ICT healthcare systems. And almost all areas, all engineering different applications areas are ICT are widely using. So I think this theme is correctly chosen 6-7 years back, and now it's a prominent area to explore more on this. Thank you very much. So I think the keynote speakers and the sessions will be, I mean, very fruitful one and very knowledge transferring, knowledge sharing one also. Okay.
Thank you, Dr. Day, for the theme address. ICT is definitely a very strong theme, and we are looking forward to learn more about it. And now I would like to invite our next speaker, Mr. Anindya Bose. Dr. Anindya Bose is presently the executive editor at Springer Nature Group. Mr. Bose is part of the global acquisition team at Springer Nature and responsible for acquisition of scientific content across the globe. He is responsible for acquisition of content in the interdisciplinary applied sciences. He has more than 26 years of industrial experience in marketing and different fields of publishing. He is an experienced publishing editor with a demonstrated history of working in the publishing industry, skilled in art direction, journals, copy editing, proofreading, and leadership. Strong media and communication professional with a master diploma in business administration, focused in marketing research from Symbiosis Institute of Management Studies, India. Mr. Anindya Bose, welcome to the session, sir, and over to you for your further address.
Thank you, Anisha. I hope you all can hear me, right?
Yes, sir, you're audible.
Yeah, thank you. So good to see Milan. Good to see you. Hi, how are you? Hello, everyone. Interestingly, I am at the ICTCS physical conference at the moment, and we are sitting in the hall. In fact, Nilanjan was giving his presentation just sitting next to me. And we are sitting in that hall where in the morning we had our physical sessions, and we were just about to finish the presentations which were given by authors over here, and immediately we have started with digital. So this is the beauty of hybrid conferences which are going on, and the beauty of ICT, which is already, you can feel it very well everywhere. I will just share my screen and give a small presentation. You all can see the presentation, right? Anisha is visible, right?
Yes, sir, it's visible.
Yeah, thank you. So basically, it's a quick fire, like 10 to 12 minutes. So there is not much I will cover over here. But to start with, let me tell you a little about the organization I work with. It is, you all know Springer very well. Now, Springer started almost 180 years ago, 1842. And then in 1924, we opened our office in Vienna. And finally, after the Second World War, in 1946, we opened our office in Heidelberg. And Heidelberg is the biggest office we have for editorial work. And especially if you look at it now, Springer is a collaborated effort of other publishers also into it, like Nature and Macmillan Publishing is also part of it. So name has changed to Springer Nature, which is more evident nowadays. If you look at this particular slide, you will find that we are operating in 4 different areas, that is education, research, health, and professional. Research is the area in which I work, and research is the area in which you collaborate also. There are a few numbers which you also can see on this slide. On top you can see 13K. That is the 13,000 is the number of books we publish each year. Then interestingly, you can see also 750K plus, which is the independent peer reviewers we are working with. This is a very interesting place to work because in publishing industry, there is a triangle, as if you see, and these triangle means like we have authors. When they write the paper, they are considered as authors. When they read the papers, they are readers. And interestingly, when they are doing the review part, so there is a triangle, but there are these roles changes, but the person remains same. So you also have definitely playing different characters at different point of time. We also publish 400,000 articles per year, which was in 2021 we have done that. And interestingly, if you look at these numbers, Springer alone is publishing 400,000 articles. That means you can see the magnanimity of this whole STM world, scientific, technical, and medical publishing world, where so many different papers are getting published. We also look at many investments which we are doing for technology aspects. Like no publishing company can survive now without a beautiful technology driven aspect to it, because digital world is taking over the physical world right now. You can very well see, in the conferences, in this particular conference, there are 950 papers were actually submitted, and out of those 950 papers, 144 papers are accepted, and only 14 papers are presented in a physical mode, and rest all 90% papers will be presented in online mode. So digital has a very big significant part of the whole thing. Interestingly, there's a link also provided in this particular slide. You can see that it's annualreport.springernature.com/2021. Springer is the first publisher who has actually come out with a report like this, which is talking about all different aspects of publishing, what we are doing and in which areas we are venturing, and also the future of publishing. So this report is a very interesting report. In case you are interested, you can actually go to this report, you can download and you can read it. Quickly, I will tell you about some author services and publishing tools, and these services you can use, and these tools also you can actually try out. And in case you think they are useful, then definitely you can use for your research work. To start with, I will just tell you about a page where, mostly people find it difficult how to connect with editors, how to find an editor in a particular area. So the best way is basically you go to our website, springer.com. On springer.com, there is a link subjects. Under subjects, if you click that subject, you will find all these subjects, which you can see on this slide. All different subjects are written over here with the links. So if you are from computer science background, you go to that computer science link and click it, and the page will open with the computer science details. And you will find there is a link, contact us or publish with us, where you will find all the names of the editors. So very easy to get connected with people who are basically working with you in tandem so that you can publish your work. There's another tool, which is a very, very interesting tool, which is called Reviewer Finder. Especially, you must have seen in your present scenario, whenever you are actually submitting any article to any journal, they are asking for reviewers, correct? You have to give names of reviewers. Now, how to find reviewers? This is a tool which can help you to do that. Definitely, you are going to find reviewers from your studies and from your references. But at the same time, there is an AI-driven tool which will help you. And here you can find reviewers. Now, I see this tool in a very different way also. A perspective is different. Like, you can find people who are working with you, correct? Who are actually working in your area, in your domain. Those are the people who you will find as a reviewer, but they can be your collaborators also. So you can find even not only reviewers, but collaborators also from this particular tool by using this tool. This is a page, another very informative page on springer.com. And this, you have to go to springer.com, our website, and under services, you will find this page. That is author and reviewer tutorials. So I always suggest, whenever you are actually submitting your paper, even for the first time, or when you are doing it for multiple times, you're doing it, but at the same time, you can go back to these pages and you just read whatever new information or guidelines or policies are available. These are the tutorials which will help you to understand the recent changes or anything which is coming up in future. Also, you will be able to, this will give you some information about the future aspects also. So these are the tutorials which are very meticulously created to help authors and editors. So you can go to these pages and you can get more information. This tool, this is a quick find tool, basically, where we call it Shared It. We started almost 5 years ago with journal articles. Now we are also using it for conference papers. Like, if you publish any paper or article in Springer, then the production team, after the publication is done, the production team will share a link with you, or you can also find this link at the bottom of the page, which says Shared It link. So now what exactly Shared It does, you can share this link with anyone and they can get access of whole access of your paper. Usually in digital world, there are some constraints, there are some limitation, because if we have not subscribed to a particular journal or a book series, then we cannot download that particular paper. But if you are sharing the Shared It link, then there is a possibility that you can do it. But at the same time, again, this also works in a reverse way. Suppose you are looking for a paper and you want to download it, and you're not able to do it because your institute has not actually subscribed that journal or any particular book series, then you can write to the corresponding author of that paper. So corresponding author can give you that Shared It link, and legally you can actually get the access of that paper. ORCID is basically an identification ID. If you mostly people are aware of it right now, but in case you don't know about it, please go and read about ORCID. This gives a very unique identifying number to you, which will identify you as a unique from your unique ID. And I always say this is like an Aadhaar card for all the people who are basically researchers. So if you don't have an ORCID ID, please go and look for one and immediately register for one. Another important area nowadays is basically open science, and the science is actually moved to open science. So people are looking for open access publication, but open access publication is an author pay model, and especially in author pay model, you have to pay, right? So you look for funders, you look for sponsors, and this is the best place to go and find. You go to this link, springernature.com/in-open-research. You will find a lot of funding details over here. There are mostly 300 plus funders in journal funding, and 65 plus funders are there in book funding also. They also do partial funding, not necessarily the complete funding. At times they do partial funding, but definitely you will get a lot of information, and there is always a possibility to get funded. And if you have a funding, then it's easy to publish open access which has a very good reachability and distribution, and even citation and or mentions are very high for any open access publication. This is another page which gives you a lot of information, like springernature.com/in/policies, because it's very important for you to understand, to have knowledge of policies. Without them, it is very difficult for you to even publish at times, especially you are dealing with a lot of data. So there is a particularly research data policies. Then there is OA publication policies. And on general note, there is publishing policies, editorial policies, and book publishing policies. So if you go to this page, now, these are the pages which you can actually refer again and again. It's not a one-time read that you go and you have to memorize everything. These pages are available and updated very frequently. So you get to learn more things when you go to these pages, and awareness of these policies are very important. We have some blogs which our author management team, or service team, author service team, they have developed, and they maintain it very religiously. Springboard is one of them. Second is the source, and third is the link. You can go to springer.com and you can look for these blog posts. And these blog posts are very important because you get a lot of information about the new information or the new movement of science, about the advancing science. And also you can write blogs from your side also, and you can contribute to. And these are all open access blogs where you don't have to pay anything, where it's freely available. You can contribute, you can participate, and you can also, I see all these platforms as a collaborative platform, because wherever you go, when you find people where you can actually talk to people, you can collaborate with them, then there is a possibility of networking also. Before I conclude, and quickly, I will tell you about 4 different books over here. First one, you can see the cover, How to Write and Publish a Scientific Paper. This is written by Robert A. Day and Barbara Gastel. This is a must book for all researchers, because you need to know, you have to know actually how to write a good scientific paper. You will get all informations in it. This is the 8th edition cover. 9th is, I think, already published or on the way. And 7th is freely available on website as a PDF. So you can very well see that. This is another book, Getting It Published, written by William Germano, and this is actually talking about the nuances of publishing, giving all kind of important aspects about publishing. Very much a book which can be referred back again and again. This is a area which is very close to my heart, which is like ethics. This is a textbook of research ethics written by Sana Lu. You can actually read it and you can use it again for reference. And finally, this is a very new book written recently by Jolango and Saracho. This is basically writing for publication. Again, talking about a lot of tools which support your publications and research purpose. So you will find a lot of information in these books. So it's always good to have these books on your shelf so that you can refer back again and again. This is a presentation or a report which we are creating for last 5 years, and they are available online. The recent one which we have developed is 2021 report, which is Unlocking Potential, talking about the SDGs. And today morning over here in the physical conference, everyone talked about SDGs, and people are really interested. And we find, in case your research is already aligned with any SDG goal or any SDG target, please go and read this particular report, which is freely available, and you will get a lot of benefits out of it. Finally, my message to you all is work sincerely, focus on quality, say no to unethical activities, because you are from a community which is very, very ethical, and be a part of it, and you should be proud of it. So stay happy, stay blessed. Thank you for this particular opportunity for you giving me and for listening me. You have my email ID on this slide, anindo.ghosh@springernature.com. In case you face any kind of difficulty in using any tools, or you think you have any queries, then definitely you can get back to me. I will be very happy to answer your queries also. Thank you. Thank you so much. Enjoy your deliberations and enjoy the conference. Thanks.
Thank you, sir, for your knowledgeful address. Springer surely plays an important part in the research and development area, as it helps authors to share their discoveries and enable researchers to find, access, and understand the work of others and support them. Moving further, now I would like to invite our next speaker, Dr. Jagdish C. Bansal. Dr. Jagdish Chand Bansal is an associate professor at South Asian University, New Delhi, and visiting faculty at Maths and Computer Science, Liverpool Hope University, UK. His primary area of interest is swarm intelligence and nature-inspired optimization techniques. He has published more than 70 research papers in various international journals and conferences. He has worked with Indian Air Force and Liverpool Hope University, UK for various research projects. He is the series editor of the book series Algorithms for Intelligent Systems and Studies in Autonomic Data-Driven and Industrial Computing, published by Springer. He is the editor-in-chief of International Journal of Swarm Intelligence, published by Indus Science. He is the General Secretary of Soft Computing Research Society. Dr. Jagdish C. Bansal, welcome to the session, sir, and over to you for your further address.
Yeah, I hope you can hear me now.
Yes, sir.
Yeah. So thank you very much, and good afternoon from India. I'm going to speak on the computational intelligence, which is one of the most important part of the artificial intelligence. Okay. So let me just introduce what is the computational intelligence. It is the study of the design of intelligent agents. In the computational intelligence, we design intelligent agents. Now, this agent may be anything: worms, dogs, a laptop, aeroplane, a robot, a machine, anything. But there are certain properties which makes this agent intelligent, and these four properties are to be satisfied, which makes so that the agent can become intelligent. For example, if you have a machine, if you have a robot and you want to make an intelligent robot, then these four properties to be satisfied. In the computational intelligence, we study the algorithmic structures, algorithms, so that these four properties can be inserted to that machine to make that machine intelligent. So the very first property in this case is whatever it does is appropriate for its circumstances. Intelligent agent always do whatever is appropriate for them. Agents are flexible also. If the environment changes, if the circumstances changing, they change their goals. They learn from the experience. More the experience, wiser they become. It makes appropriate choices. If more than one choices are available, in that case, the intelligent agents is able to distinguish that which choice is good for me. In general, the computational intelligence can be said as the computational part of the artificial intelligence. So actually, the computational intelligence is a special class of artificial intelligence in which the intelligence emerges through intensive computation. IEEE Computational Intelligence Society has also defined the computational intelligence formally. It says that it is actually a computational paradigm which is motivated by the biologically, naturally, and linguistically. There are certain areas of coverage in the computational intelligence, which are artificial neural networks, evolutionary computation, swarm intelligence, artificial immune system, and the fuzzy systems. There are certain challenges also in the computational intelligence study, that most of the computational intelligence studies are actually taking into account some randomness. Some one or more kind of randomness is there, stochastic components are there. It is not a traditional deterministic approach, and therefore the computational intelligence results are not always repeatable. The whatever the outcome using the CI techniques you are giving, you cannot give the 100% guarantee that the other one also can get the same output. This is the problem, and therefore sometimes the reliability decreases as compared to the traditional methods. However, because of the intensity of the complexity of the problem, the since the problem are becoming more and more complex, the traditional methods are becoming are no longer able to solve those complex problems. In that case, the computational intelligence based algorithms based methods are the only option to solve. And therefore the computational intelligence algorithms, however not 100% reliable, they are the only option to solve such kind of complex optimization or complex problems. Of course, there are the classification of the computational intelligence, out of which this ANN is one of the most important part. Evolutionary swarm and evolutionary algorithms are the basic my research area. So in the evolutionary computation, genetic algorithm, which was introduced in 60s, is one of the most famous, most important algorithm, and still it is very good algorithm. People are working in this algorithm, people are using this algorithm for solving their problems. For example, let me tell you the Japan's bullet Shinkansen N700 trains, that aerodynamic node-shaped design was actually designed by the genetic algorithm, and is still this is the best design available, and genetic algorithm has designed that. Aeroplanes, aerodynamic wing shape design usually designed by the genetic algorithms. Car design also being done by the genetic algorithms. Uh, Nowadays, the drone swarm in the drone swarm, the coordination among the drones is also planned using the genetic algorithms. Differential evolution is another category in this algorithm, uh, which is relatively recent and simple algorithm in the field of evolutionary computation, with a minor change with the traditional evolutionary algorithms, because in the traditional evolutionary algorithm, crossover is the first operator and then the mutation. In differential evolution, mutation is the first operator and then the crossover. Biogeography based optimization is another one very recent algorithm which was proposed by in 2008. In the year 2008, it was proposed by one US scientist, Dan Simon. Swarm intelligence based algorithms are relatively more uh, popular these days as compared to the evolutionary algorithm, because usually they consider less, they are more accurate, they are relatively new, and they have inbuilt diversity maintenance mechanism, particle swarm optimization, and ant colony optimization algorithm. These two are the one very famous algorithms in this category, and let me tell you, around 80% of the market share is covered by these two algorithms. 1992 it was proposed, and in 1995 it was proposed. Ant colony optimization algorithm is inspired by the foraging behavior of ants from one point to another point, and particle swarm optimization algorithm is inspired by the birds flocking or fish schooling behavior. If one can understand these two algorithms, most of the other algorithms will become very easy. In 2014, we also introduced one algorithm in the swarm intelligence category that is called spider monkey optimization algorithm. This algorithm is inspired by the foraging behavior of spider monkeys. Actually, spider monkeys are the wild monkeys. They live in the deep forest, and they, when they suspend with the tree branch, they look like a spider. So they are, therefore they are called the spider monkeys. They have a very special kind of foraging behavior, and this special kind of foraging behavior actually inspired to develop an algorithm. And what is the special kind of foraging behavior? That they live in the society of 50 to 60 monkeys together. Whenever in the morning they start food foraging, they go together, the entire group go together. Whenever at any particular space they realize that there is a scarcity of food, in that case they divide themselves into smaller parts. This is called the fission process. So during the as a fission process, they divide themselves into smaller parts, and these smaller parts search for the food in different areas. And when in the evening, all these small parts or subswarms get together, and this is called the fusion, and they again share the information. They come to the tree or the habitat wherever they are staying, and then they share the information with each other. Okay, that this particular group went in this particular direction of the forest. What was the food quality, food amount, how far it is, what is the competition there for getting the food. Everything is shared with these small groups on the tree. And in the next morning, whoever has the best information for the food source in the forest, they start in that particular direction. This is the way how they find the best possible food source in the forest, by this cooperative behavior. So this cooperative behavior founds the most optimal location. Similarly, in the optimization problems, the most optimal solution can be found using this kind of collaborative behavior, cooperative behavior. And based on this behavior, we have developed uh, this research, spider monkey optimization algorithm. Artificial bee colony algorithm is another in this category, which is inspired by the foraging behavior of honeybees. Honeybees inspired honeybees, how the honeybees move from one point to another point, how so they they do the dance instead of sharing the information. They do the dance, that from where I'm coming with this dance. They perform three types of dances: waggle, tremble, and round dance. Based on these three type of dances, other bees understand that from where she's coming, uh, how far the food is, which kind of food is, how much nectar the flower has. And this is the way how the most optimal location of the food source is searched. So this is the same way, like a spider monkey optimization, one can find the optimal solution using the artificial bee colony algorithm. In ant colony optimization algorithm is basically to find the shortest path from one point to another point, but later the variations of ACO developed, which solves the continuous optimization problems also. So that's all from my side. Actually, genetic algorithm is also a vast area of research. Um, if all these evolutionary computation are actually based on the Darwinism principle of the survival of the fittest. So that's all from my side. Thank you so much. If you have any question, I can we can discuss that. Yeah, I cannot see anybody, but yeah. If you have any question, I logged in with Ms. Anida Bose login. My name is Jagdish Bansal. If you have any question, please let me know. Yeah. I hope. Yeah. Yeah, Anisha. Is it okay?
Yes,
Can you hear me?
Thank you, sir, for your knowledgeful presentation about computational intelligence. It is very useful in addressing real-life problems. Its algorithms and approaches makes it a good fit for real-life complex problems. Now, I would like to invite our next speaker, Professor Milan Chuba. Professor Milan Chuba is currently the Vice Rector of Signum University, Serbia. His research interests include mathematical queuing theory and heuristic optimizations applied to computer networks, image processing, and combinatorial problems. He is the author of more than 150 scientific papers and a monograph. He is also a co-editor member of the editorial board, scientific committee member, and reviewing for several international journals and conferences. He is a member of various international and scientific organizations such as ACM, IEEE, AMS, SIEM, and FNA. Mr. Milan Chuba, welcome to the session, sir, and over to you for your further address.
Good afternoon to all the participants. I hope you can hear me. It is a great pleasure and honor to be part of this conference. Actually, I'm not in Europe anymore. even though I have my functions here, but starting last spring, I'm in Texas, in United States, and I just came from the airport 2 hours ago. I had a, let's say, interesting journey consisting of 5 flights from San Antonio to Belgrade. And then, of course, it took about 2 days and 2 nights because in 5 flights, one must be late and then the next one is gone. And I spent a whole day at Heathrow in London and so on. And unfortunately, I always say, I hope this is the last time that I cannot come to India. Now this is really challenging because Texas is just on the other side of the globe. So I can go east or west, it doesn't matter. It is the whole globe to come to India, but I'm sure next time I will make it to India. So this time we have to do it this technologically advanced way by video link. So I would like to say a few words about very interesting topic and very good topic for young researchers where good results can be made. Professor Nilanjan, they mentioned super smart society, cities, and so on. And let's say example of super smart is car without driver. That is something that is becoming rather popular last couple of years. And another area that was also mentioned is medical diagnostics, which is now much improved and revolutionary, better than it was before. So it is interesting that all these things so diverse, like medical diagnostics, self-driving cars, and many other things are really connected because they are based on a very simple artificial intelligence problem, and that is classification problem. And classification is something that is rather simple for a number of entities that have certain features. Based on those features, we have to determine which of those entities belong to certain class and which don't. So, you know, you may have a couple of images and then you want to find out what is in that image. It looks like much simpler problem, but actually, if you look at the self-driving car, it's not the robotic part that is turning steering wheel, accelerating, braking, and so on. That part is relatively simple or not so difficult to make. What is very difficult is that to drive a car, we have a number of sensors, most often cameras, front, side, rear, different types, infrared, regular light, and so on. And then based on that real-time information, let's say from cameras, we have to slice them into individual images, and then we have to analyze those images. And now when we look at a single image, we have to make a decision. Is there a stop sign in this image? If there is a stop sign, then we have to start the action to stop the car. Is there a pedestrian in this image? Is there a bicycle in this image? And so on. So this complex task of driving a car is actually a huge series of many classification tasks. So anything actually that we are doing in this super smart society is based on classification. And for classification, we had many different tools for decades. And we were relatively successful, but what we have last couple of years is really a revolution, something that is qualitatively changing the approach and the results, and of course also posing new problems. So I can give you an interesting example that interesting classification task, but in the past century, was handwritten digit recognition. it was an interesting practical problem because we needed such systems to do mail sorting, where each envelope you have zip code written by hand. And also in bank sorting checks, where people write checks by hand. And now to automate the procedure, banks needed a system that can look by camera to those checks and decide what is written there. Of course, that is a challenging problem because handwritten digits may be very different. People have different handwritings and it can be very, very difficult. So as a practical problem, it was interesting maybe 30 years ago, maybe more. And it was solved. So all these systems for sorting mail and bank checks, they were developed and they work fine and so on. But what is interesting, it remained as a benchmark problem. So a huge database of handwritten digits was collected at University near in California. That base is known as MNIST database. And after that, for decades, all the researchers are using that database as a benchmark. So for every new classification method, we use that old database and see how it compares to other methods. And what we had for 20 or more years, we had slow development. We had different methods, let's say support vector machines were a huge improvement and so on. So every few years, we get a new method, we get refinements of all methods, and then we get better classification. So let's say 15, 20 years ago, we usually had a huge team of researchers, very qualified, and they work a couple of months on a new method or improved method. And then finally, they test it on that benchmark database, and they publish what is the improvement. And we were going slowly from 98% to 98.5, 98.7, 99, 99.1, and so on. It took decades for that slow improvement. What happened last couple of years with deep learning or convolutional neural networks, we now have everything together. We have hardware that is usually graphics cards, which are the most powerful processors that we have now. We have a lot of data that was collected by mobile phones and so on. And now everything came together. So powerful tools were developed. And the situation today is that an introductory undergraduate course, when we start talking about that topic, we can, using these tools in one class, single class, develop a small convolutional neural network model that will use that MNIST database, and that first attempt will have better accuracy than 99%. So what 10 or 15 years ago, we had huge qualified research teams working a couple of months to make a small improvement. Today, in undergraduate artificial intelligence class, in 1 hour, we make a starting model that is better than 99%. And then, of course, next hour, you can make improvements. So if you started with 99.1, you can make it 99.2, 0.3, and so on. That is with undergraduate students in 1 hour. So that shows that it really is revolutionary. However, there are some problems that with that approach. It is so revolutionary. It's too good, actually. And then it may become dangerous. So I will not go here into details because there is not enough time, but I will say just in few sentences that most important quality of convolutional neural network that are really the driving tool of this revolution is that they are using many features. So, as I mentioned before, if you do medical diagnostics, you look at the patient, and now you care about certain things when you are trying to make a diagnosis. In old days, the physician will look at the patient's eyes, tongue, skin, do some palpation, ask few questions, and so on. So it was very limited number of features. Now imagine when you have modern lab and blood works. Now suddenly you have much more data. You just take a few drops of blood, and then you can get hundreds of different parameters that are not visible to a human eye. You get it from the lab, and now you look at the paper, and there you have 200 new features, red blood cells, different types, and all those things that you can find in blood. It is a different type of diagnostics. For old-fashioned physician, it may look like a magic. He had 10 different features, and he was trying to decide based on that. New physician has only by a simple blood work, has hundreds of features. And now using that, of course, diagnostics is much more precise, much easier, and so on. Now, what convolutional neural networks introduce is using not hundreds, but thousands and maybe even millions of features. Features that we don't have names for. Because before that, when we went to 200 features, of course, we have a name for each of those parameters. If it is 500 again, we intentionally introduced it and we know what it is. And then, of course, it is good, we know what we are doing, but it is also limited because we are limited. Now, with convolutional neural networks, we let the process go automatically. We just feed the images, because usually it's about digital images. We just feed the images to the system that we made, and the system will automatically extract features and use them. But it will extract maybe 100,000 features. So for those 100,000 features, we can never invent names. We don't know what they are. It's not color, it's not texture, it's something else. And then, because of that huge number of strange features, the system is very powerful, but we don't understand it anymore. And that is the problem. On one hand, you get excellent results. You can make a diagnostic system, or you can make a self-driving car that is doing excellent job. That system is beating human experts in diagnostics. And that car is driving better than average or good driver. So that's good. However, errors do happen, very rarely. But when they happen, then of course we feel uncomfortable when we have human experts make error. We somehow are ready to tolerate it, and we try to understand how that happened. Now, when artificial intelligence system makes error, it's very difficult to say why that happened, and the reason may be very strange. And the result, you know, that particular error can sound very strange to us. So right now we are in that at that stage, as again Professor Nilanjan mentioned, we would like to develop systems that are explainable. But it is in a sense contradictory, because they are powerful because they use so many features. And if they use so many features, they cannot be explainable. You cannot explain a million features. So we are fighting that battle. But in any case, for this conference, for young researchers, this is a very good area, because the method is so powerful. You can look at anything that was done before. You can apply this new method, and you will certainly get better results than before. So the purpose of research is improving results. Sometimes we have very different areas. For example, you know, in medicine, fighting cancer, that's taking decades and very little progress and so on. But here, in a convolutional neural network applied to anything, you can practically be sure that in a very reasonable time, you will be able to improve the previous results. So for young researchers, it is very good. You don't have to worry that it will take you years to get some results, or maybe you will spend years and then finally you will discover that your approach was not leading anywhere. Here, the results are practically guaranteed, and in that sense, it is a very good area. From the other points of view, this philosophical, political, how we deal with that power, how we use it, and so on, it is more complicated, but also challenging, and we also work on that. So, for this short speech, I thank you, and I wish you fruitful exchange of ideas, future collaboration, and hope to meet in person as often as possible, but use these video link possibilities when necessary. Thank you, and all the best to everybody.
Thank you, Professor Tuba, for your knowledgeful address. We can definitely see that super smart society's goal is to achieve a sustainable and inclusive socio-economic system enabled by the technology, including AI, and we look forward to see its impacts in the coming future. Now we will move further, and I would like to invite our next speaker, Dr. Vijay Singh Rathore. Dr. Vijay Singh Rathore is a professor and director outreach, Jaipur Engineering College and Researcher, India, and secretary of ACM Jaipur chapter, the past chairman, CSI Jaipur chapter, having teaching experience of 20+ years. His core research areas include internet security, cloud computing, big data, and IoT. He has organized and participated in 25+ national and international conferences of repute. Dr. Vijay Singh Rathore, welcome to the session, sir, and over to you for your further address.
Thank you so much for such a nice introduction. And I am joining from the account of Mr. Aninda Bose, because there is some issue in my mobile video. So I hope I am audible to all of you.
Yes, sir, you're audible.
Yeah, thank you so much. So I am here to give the vote of thanks. I would like to thank all the participants who have joined here, and also I have like we had this physical mode conference also here in Chandigarh. We are sitting in Chandigarh right now. In the morning we had the physical mode inauguration of the conference. It was very nice, and I'd like to thank both the physical mode and this offline online mode participants who are going to present their papers, and I wish them all the best. I would like to say thanks to Professor Milan Tuba for giving such a nice presentation on CNN and all these ICT-enabled technologies. Thankful to Aninda Bose sir, who has provided such a nice information on the publication part and Springer, what Springer is doing and what are the different research ethics, and he told many things about research publications and how to avoid the plagiarism and how to abide with the ethics protocols. I would like to say thanks to Professor Nilanjan Day and Professor Jagdish Chandra Bansal and all the other speakers who have spared their time, and they are going to deliver some other invited talks also. So thanks to all of you, and we wish that this conference will bring together the researchers, academicians, and the faculty members across the world with the new information, latest trends in the ICT, and we hope that your research will be really beneficial to the society. So I wish all the participants that they present their work with full of enthusiasm, and whatever questions being asked to you, just try to give their proper responses. And if you don't have responses right now, then you can just try to get the answers and then do the replies future. So again, I'm thankful to all of the participants, all the speakers, and especially the organizers for organizing such a nice conference and taking pain to organize the conference in physical mode as well as in the online mode. Thank you so much to one and all. Thank you so much. Namaskar.
Thank you, sir, for your knowledgeable address. And it was a sheer joy for all of us to listen to the speakers, and we hope to see you again in our upcoming conferences. Now that we have come to an end of this inaugural session and we have different technical sessions planned for the day, I request all the participants who have been attending the session over the time to kindly attend those sessions. Further, it's a request to all the participants to join the technical session as per the schedule. The timings for the technical session 1A is 3 to 4:30 p.m. and for the technical session 2A is 5 to 6:30 p.m. Each session will be delayed by 10 minutes. Further, I sincerely thank everyone for their valuable presence in this session. It is our pleasure to have you all here with us, and we will be happy to have you in the 8th version of this conference in 2023 in physical mode. Now, I request you all to please switch on cameras for a snapshot of this virtual conference. Okay, thank you so much, everyone. We will start the technical sessions within the next 10 minutes. Thank you so much again, and take care, everyone.